Hey everyone, welcome back. I'm Dr. Bolton, and today I want to talk to you guys a little bit about database management systems. I think this is an important skill for you guys to understand and know. As data scientists, many of you guys will be working with lots and lots and lots of data, so I think it's important for you guys to understand how we store, manage, and retrieve data to be able to do all kinds of different analysis with that. So with that, let's jump right into it and go a little bit over what we talked about last time. And that is, what are we talking about when we refer to data? So data refers to the different facts concerning objects and events that can be recorded and stored on computer media. All right. Think about all of the billions of social media users that are out there, all right, and all the mobile devices that are collecting heaps of data on us, all right. Trillions of sensors installed in traffic and intersections that might be monitoring different environments, and there's large amounts of data that's being collected on us every day using things like all of our smart devices, Alexa, Google, smart cars, smart cities now. These are all collecting data about us and the physical world. All right, and so a couple of terms here, different data structures. So structured data is what we consider to be the actual facts, something that can be stored. Think of it as a Excel document, a cell. All right, so this would be like a string, a name, an address, a telephone number, a date of birth, anything that refers to a actual fact of data. Unstructured data is a little bit more difficult to deal with. These are what we call objects, right? And they can oftentimes include things like documents, maybe a Facebook post, images, sound, video, these things that don't fit neatly in nice Excel cells. So think about that when you're thinking about the differences between structured and unstructured data. And a little bit of what we talked about last time, just a reminder of what big data is and how we look at that different from just small bits of data. And it's a term that's really used to refer to the data sets that are too large or too complex for our traditional processing application software. And those include things like the three things that are included to be able to define what big data is volume. So this is the quantity of generated data that's being stored. All right, think about a small Excel spreadsheet. If it's about a kilobyte or a megabyte in size, even though it may have a lot of different rows and columns. All right, one instance of that might be one file that's sitting on your computer. So that might be a small amount of data, as opposed to say a database containing the entire human genome, for instance. The type of variety of data that we're talking about, this is the type and the nature of the data. So think about that small Excel spreadsheet again. That's just a single table that sits on a computer in a single instance. Whereas we're looking, as we move out away from or radiate into the circle, we could be looking at things like photos on your phone or on social media posts, videos, audio recordings. All of these create different varieties of data. All right, and then finally the velocity. How quickly? What is the speed at which that data is actually being generated and processed? And so, if it's just a single instance on your computer, that's just a very small data velocity. If we're collecting something in real time, say like a smartwatch monitoring your heart rate at say every couple of seconds or every couple of milliseconds, all right, that's close or near real time. And so lots more instances, the speed at which we're collecting that data is much higher. All right, so just a little bit about how we define what that big data is. All right, and so what is important for us when we're dealing with different variety of data, different structures of data, whether we have big data, small data, all right, what are we doing that? So when computer based data processing was first available, there weren't any kind of databases. Computers, 50, 60, 70 years ago, didn't really concern themselves with storing data. They were processing a set of series of algorithms to extract some information. All right. And so, to really be useful in this day and age, we need to house that data in some way, maybe manipulate it in some kind of way, process that information or process that data to extract some different kind of information from it. And so the database approach is really to overcome those early flaws, all right, and being able to process data. So we have some sets of data, all right, whatever that is, all right, video, audio, text files, statistical values, whatever. We have some data. So we need a system that is going to help us process this data to extract or get some information. And so we want to get that information to gain some type of knowledge. And so this is really what we're doing when we're doing data processing. And so what is a database in this sense? So a database is an integrated collection of information that allows us to store, manage, and retrieve data, by defining the nature of the data and the relationships among that. All right. And so there are a couple terms I want you guys to be familiar with as it relates to a database. And one is an entity. All right. So an entity is a person, a place, or an object or an event that is in that user's environment. And this is about what is the information that we're trying to collect and maintain in our database. All right. Attributes are the actual data instances in which you want to capture. So this is what you're interested in capturing as it relates to the entity, right? And then there are relationships, and this is the association between the different entities that you might be collecting. All right. And so we need efficient algorithms and data structures that are going to help us store this data. And so after we store it, we also need systems that are going to help us retrieve the data when we need it, manage the data, and manipulate the data when that's necessary. We may want to insert more data later or update the existing data that's in the system. So to be able to do all of this within a database, we really need a database. We'll talk about this in a second, database management system and the different levels of that. There are a couple of different types of databases. These are the ones I want you guys to be familiar with. And so one that we're going to really look at over the next several lectures is looking at a relational database. And so a relational database management system uses a centralized or a structured type of model. All right. And this means that it uses different tables as the particular entities to be able to collect those attributes. All right. And then these tables, which are entities, right, have different relationships between them. All right. So I can have a student, right, table or a student entity that has a relationship with courses. All right. And so that relationship between them, we'll talk about how to explain that relationship. What is the relationship with those entities? All right. Some examples of that, just like I said, students, courses. This is used a lot in banking systems and flight reservation systems use this. To separate those and the differences between relational database systems, there are no SQL or no SQL database systems. So like I said, relational database systems use centralized or structured models. These are for unstructured models. So a NoSQL database will allows us to store different things like graphs, video, text documents, all right, because it's in a non-tabular form, all right. So it doesn't use these tables to store relationships. It uses what we call a key value relationship to be able to store information, all right. The Hadoop and Spark database management systems are really designed for being able to look at big data. All right. And so these do not necessarily work on the operational or transactional workloads like the relational databases or the NoSQL databases. It really focuses on being able to run different applications or different analytical algorithms on top of the actual data. And so it's a little bit out of the scope of this course. I'm not going to really go into how these management systems work. We just don't have enough time in this course. There are courses out there available in computer science and IoT, which would really focus on looking at big data in itself and how these systems work together. If you're interested in that, just contact me. I can give you some more information. So some of the benefits of looking at a relational database. Here are some of the key components or key benefits to doing that. One is data independence. So think of this as like a person building the application or the front end application doesn't necessarily need to know anything about how the data is actually being stored or organized within the database. All right. And so there's logical and physical data independence. We'll talk about this a little bit more in a second. Data efficiency. All right. The developer doesn't need to have any or know how the data is actually accessed or retrieved for them to be able to develop or create their application. All right, and so there's data efficiency in that sense. The data administration, the one location you store on the or the location that you use to store on the data, you can have different locations for different people who have access, right? And so you might have one location to store the data. You might have one portal to be able to allow a person who designed the database to access information, and you might have one person who manages it different access. So you can create different access points for different people who need to get to different parts of the data. All right. This also allows for concurrent access. You can have multiple users that are accessing the data at the same particular time. Within the data models or within the database management system, you have a couple of different data models. The data model is the collection of the different concepts for being able how to describe the data within these particular tables. This is what we're talking about: the entities, the attributes, the relationships. All right. The schema itself is going to be a description of that particular collection of data using the particular model that you have. And so these two go hand in hand. I'll show you the hierarchy on this in a second, but understanding that there are schemas and models within your database management system. The way that these relationships particularly work are using the tables like I've explained. All right. And so the relations are referring to the independent tables themselves. So each entity is a table, whether you have a student, a course table, whatever that is, a patient table, a disease table, whatever. Each of these entities or tables have a set of columns. All right. And each of those columns are going to represent an attribute within that entity itself. All right. So, for instance, like at the top here, we see just a basic column table, right? And the example is a student who might have different attributes like a student ID. They might have a last name. They might have an age. They might have a social security number, whatever that is. Those are going to be represented by the attributes, and each of those attributes will be an independent row. Okay. And so these are our this is our relational model that we're using. All right. And so the schema is actually going to be a description of the relational model, and that can look at in a couple of different ways. All right. And so that allows us to set up different levels of extraction using our schema. All right, and so there are a couple of different types of schemas. All right, there is a conceptual schema and there is a physical schema. The physical schema is really the way that the data is physically organized and stored in the database. All right. So how is it being stored? Is it stored on a independent computer like what I'm working on here, just a single a computer that's networked together? Is it stored on a more complex system such as a database server in some instances? Is it stored at the university? Is it stored on the cloud? Is it in AWS? All right, so this is how is the actual schema or the actual data being stored. All right. Conceptual data is how the data is logically being represented. So we've been talking this whole time about the relational model. So it's using these different tables, all right, as specific entities. And so how is each entity being used or accessed, and what is the relationship between each of those entities? All right. And then the views are what we call the external schemas. And so you can have multiple views. And this represents how the user might actually see the data. All right. So I might need to see a whole relationship of a bunch of different types of entities or tables, all right, that I have access to. But you might have another subset group of users who maybe only need to access a couple of tables, right? They don't need to know all this financial information over here on a student group or anything. So you can limit the types of access that users have to your data by these views, by these instances, which are also called external schemas. All right. And this is just a simple example that you might see how it represents. This is a university database I've kind of been talking about, but you might have this external view, or actually let's talk about the physical schema in this. So these are actually stored in unordered files and indexed on the first column. So these are stored on a physical database somewhere, all right, in some order files in some kind of conceptual way, all right. And so they're stored on a disk, some hardware storage, and they're being sorted through some student ID, some instance. That's what the index is, and so it's indexed on the first column of the students, and that's kind of how you're going to access that particular physical information, right? The conceptual schema is the tables themselves. So here we have three different tables, three different entities. We have a student entity, for instance, and inside that student entity, there's a student ID, and then we have just the file types that we have here, which is a string, all right, the name of the student, which is a string, some login information, their age, all right, all of that's there. We have another course entity, all right, and that has a course ID, all right, with a string, which is a string, all right, the name of the course and how many credits the course is. It makes sense that all of those would be different attributes in that particular entity, all right. And then we have enrolled, all right, which is another entity or another table within that database. All right, and that has a ID that is actually the same thing as the student ID. So now you see this relationship as well. And then it also has the course ID within that entity as well. So now there's a relationship between students and courses in this enrolled table. All right, and then the grade, which is another attribute within this table. So you now see that the indexing in the physical schema is a relationship between the students and the course information that we have there. And then the external view or the external schema, all right, is what the person who is accessing this database can see and actually has information too. They want to know the course information, all right? And so what they get is the course ID and some type of enrollment, which is probably some algorithms developed through all this stuff. We'll talk about how to do all these things. You'll see all that as you move forward, and you can do different algorithms within your views and your schemas and all that stuff as well. All right, so this is a quick introduction into a database management system. If you have any questions, just get in touch with me, and thanks. Have a great day.